Hello guys, welcome to this video. In this video, I'm going to show you how you can calculate angle between planes of unit cell of a crystal structure using Python-based command line tool. So X-ray-codes is my GitHub repository where I have the code to calculate angle. And let's review what is a crystal and how we specify the plane simply from Wikipedia page. So in crystallography, crystal structure is a description of ordered arrangement of atoms, ions or molecules in a crystalline material. Basically, you have a unit cell and that cell is repeated basically infinite number of times to create the crystal structure. Now there are more than one type of unit cell. The simplest one is cubic unit cell, where all the arms have the same length A and all the angles are 90 degrees. And if they have a different arm length but all the angles are 90 degrees, then one of the example is tetragonal, where A and B are the same, so you have AA but C is different. You can also have a hexagonal system where A and B are the same, so you have AA but C is different, and the angle between A and B or two consecutive A's is 120 degrees instead of 90 degrees. And in Triclinic unit cell, all the angles and all the arm lengths are different. Once we have the unit cell, you can specify any planes using an index system called the Miller index. In my program, I'm using 3-component Miller index system, even for hexagonal system. So HKL, these are the indices. And they have shown some examples here. O1 plane is that gray shaded plane, and 100 is this other plane. 101 is that plane that goes from one corner to the other. Now that we know that to construct the unit cell, we need arm lengths and angles, and we also know that we need to specify the planes using Miller indices, we can calculate the angle between planes using my program. To run my code, I'm going to use a Fedora system, and in Fedora you can install Conda and all the required packages in this way. You can use any method to install these packages. I prefer Conda. I have Conda installed already, so I'm just gonna create a new environment, XRD, with Python 3.10. I'm gonna activate that environment, and then I'm gonna copy this line so that I have all the packages installed in this environment. Yes. And while it's doing that, I can download this repository from GitHub. One of the way to download this is by zipping everything. And I have it downloaded and I have the packages installed. So it's here in my downloads folder. I'm going to extract it, and let's go inside that folder. And here I have all the files, and to calculate the planes or angle between planes, I just need this file. So I'm going to run Python miller-planes.py-h to display all the helps or description for command line arguments. Let me go to full screen mode. So -a is to specify the lengths of different arms A, B, C. They must be separated by commas and there should be no space between them. And for angles, I'm using capital A dash capital A, and for index 1 and index 2 I'm using dash I1 and dash I2. So if you specify plane 1 using dash I1 and plane 2 using dash I2, then the program will calculate the angle between I1 and I2 plane. So let's create a simple unit cell, 10, 10, 10, a cubic system. Angles are 90, 90 and 90, and I1 is say 1, 0, 0, and I2 is 0, 0, 1. We already know that the angle is going to be 90 degrees. Let's see if the program can calculate it correctly. So as you can see, two shaded planes are at 90 degrees, and in the program it says it's 90 degree. So it's calculating the angle correctly. Angle between 100 and 001 is 90 degrees. So what about other planes? For example, 101 plane. So now, as you can see, angle is 45 degrees in the picture, and here as well is 45 degrees. What about 102 plane? It's different, but it's 26 degrees. If you have 101 bar plane, then you specify that plane using a minus sign. So here it's gonna be 1, 0, minus 1, and that's the plane 101 bar, and the angle between 101 bar and 001 is again 45 degrees. Now if you have 1 bar or 1 plane, this is how you'd write it, but this program kind of gives an error if there is no space before the first minus sign. And yeah, now the angle is here again 45 degrees. Now this was a simple system. How about a complex system? For example, for hexagonal system, A is 10, B is 10, C could be different, say 4, and if C is different, then that gamma angle would be 120 degrees. In that case, let's see how the unit cell looks like and what the angle is. The unit cell looks like this. Let me go to full screen. And the angle between two planes is shown here, which is 24 degrees. As a last example, let me show you. So say it's 102 and 01 plane, angle is 13 degrees. All right, but what if we want to calculate angle between 102 plane and YZ plane? Because here 01 is the plane that belongs to the unit cell. If I say 100, then that plane is here. That plane is a part of the unit cell. So the angle 76 degree is the angle between that plane and that plane. Both of them are part of the unit cell. Now if you want to calculate angle between that plane, which is 102, and YZ plane, then you need to specify another flag -C. That way the second index 100 will be considered as an index of a cubic cell. Basically in this case it will be YZ plane, the angle between YZ plane and 102 plane is here 78.7 degrees. Thank you for watching this video. I hope this program helps you guys. If you have questions, feel free to write it in the comment.